channel Code with Fernando. In this video, we are going to see Module 6, Data Pipelines and Functional Composition. Okay, introduction. Reactive programming makes it easy to build simple, readable pipelines that process asynchronous data. In this module, we will learn how to use key operators like map, filter, reduce, and flatMap. We also going to be follow functional best practice, such as how to use immutable data, avoid shared immutable state, avoid side effects inside the stream. Okay, so these techniques help you build safe, testable, and reactive systems that are easy to understand and maintain. So this is really important to understand. What is a data pipeline? A data pipeline is a series of steps that process, transform, or enrich data. A simple step. Series of steps that process, transform, or enrich data. A series flows from a source to destination. Okay, let's think of it like an assembly line. Raw data enters, each state transforming, refined output emerges. In reactive programming, pipelines are built using operators like map, filter, and flatMap on flux and monostreams. Okay, so some key characteristics about this. They're composable, steps as modular and reusable. Declarative, you define what to do, not how. They're lazy, execution happens only when subscribed. Asynchronous, supports non-blocking flow and back pressure. Let's continue with our code demonstration about data pipelines example. So let's create a flags of type string. So let's call this books and let's add the information. Just let's call this Java 101. Then we have Spring Action, then Java Programming. Okay, what do we do? Let's use some operators. Let's use some filter, for example. Okay, filter. So we're gonna filter the books that contain. Let's call this title first. It's better. So title contains Java. So we are going to filter the books that have that contains this Java inside this title. Okay. So we know that this could be this book and this book. This book will be out. Okay, then map and let's uppercase to uppercase. Okay, finally let's subscribe. We know. So let's use this way. System out print. Okay, let's see this in action. We're going to see Java 101 and Java programming books. Okay, and they both are in uppercase. This is a simple pipeline. Okay, let's continue with what is functional composition. Okay, functional composition is a practice of combining small, simple functions to build a complex behavior. Okay, combining small, simple functions in order to build a complex behavior. Instead of writing one large block of logic, break it into small, focused steps. Connect each function like puzzle pieces. Each step takes input, processes, passes results forward. In reactive streams, each operator, like map, filter, flatMap, is a function. Okay, chaining operators creates a clear, readable data pipeline. Encourages modularity, reuse, and testability. Okay, let's continue our code demonstration about functional composition. Okay, let's begin by creating our stream. Usual flux string. Let's call this book titles. Flux. Just okay. Let's make it like this. Notice there is a space in here. Okay, that's on purpose. Input action. The other one will be called the other book will be called Reactive Programming. Programming with Java. The other book will be called Clean Code. And finally, we have Java concurrency. Concurrency in practice. Okay, it's nice. I know these spaces are on purpose. Okay, then let's create our functional steps. Okay, so what do? We take the book titles, and finally, okay, let's create our flags in here. String, and let's call this process. Process. Let's take the book titles, and let's map. Let's use this string class, and let's use trim. So we are going to remove extra space. Then, okay. Oh, now this uppercase. No, let's lowercase. It's better. Okay. Okay, lowercase. Then what do we do? Let's filter. Okay, let's filter those books with title that contains Java. It's going to be lowercase because in here it's already lowercase. And finally, let's add some, let's call it decorator. Just recommended. And let's print the title here. Nice. Just as some format. Nice. Okay. Okay. Here. Semicolon. Now it's working. Okay. Now what do we need to do? We need to subscribe. Process and subscribe. System out print. Simple as that. So first of all, we remove the spaces, okay? Then we lowercase all of the titles. After that, we filter the books, which title contains Java. Then we add some format, okay? Just to see nicely. Let's print this. Nice, because this book contains Java, this one, and this one also. That's why we only see two, because we are filtering here. Okay, so by doing this, we are I'm showing you how to use functional composition. Why functional composition in reactive programming? Functional composition helps you build clean modular data pipelines by chaining small focus operation. What are some benefits about functional composition? Clarity. Each step is simple and self-contained, easy to read and reason about. Immutability. Data isn't modified. Each operator returns a new value, avoiding shared state issues. Side effect isolation by using do on next, do on error for logging. Okay. What about reusability? Compose a small function into larger flows. Reuse steps across pipelines. Testability. Easily test each operator up to the full stream using tools like Step Verifier. Okay, later we are going to see those about testing in reactive programming. In short, functional composition makes reactive code cleaner, safer, and easy to test. Finally, immutability and side effect isolation. Immutability, which means data is never changed directly. Operators like map, filter, and flatMap returns new values of streams. Predictable behavior. Pure functions make data transformations easier to reason about and debug. Threat safety. No shared mutability state means fewer concurrency issues and race conditions. Side effect isolation. Actions like logging or saving into a database should be handled separately using do on next, do on error, or do finally. Clean design, separating side effects from core logic, keeps your pipelines pure, testable, and maintainable. Best practice, build transformation logic with small, stateless function and isolate all side effects clearly. Let's continue with our code demonstration about immutability side effects example. Okay, let me create a static method. This method will return a mono type string. Okay, let's call this method save to database. This method will take a title string. Okay, return mono. Just save, open, then title, then like this. Okay. Later we are going to see why do we have created this method. Okay, this is static method. As usual, let's create our flux. Let's call this titles flux just, and let's call this clean code. What about this effective Java? Amazing book, by the way. Reactive programming with Java, finally. In Java. Okay. Now let's put this in action. Let's take titles. Okay, in here we are going to transform data using some operators. Okay, so we use this take map and title. And okay, let me show you. Let me do this. Put some space in here. Okay, some spaces. I'm gonna trim this. I'm gonna remove the spaces. By doing that, we use trim. Okay. Next, that we do to uppercase. So map title and title through uppercase. Okay. Then let's see some side effect. Okay, so by doing that, we need to use do on next. Do on next. So in here, we are going to print something interesting. We are going to print transform title. Okay, next, let's simulate. We are using this method, save to database. Okay, so simulate saving. Why do we see this side effect? Okay, strange. That's why we need to use map. When do we use flatMap? In whenever we want to return a mono or flux, okay, we use map, flatMap. Okay, now we are returning a mono. That's why we use flatMap. Okay, so because this is a static method, we use immutability, side effect sample, save to database in here. Okay, I prefer to use method reference. Save to database. Simple as that. Okay, now more logging. More logging. For doing that, we need do on next. And here, what about save? And let's print this. Save to database. Okay, and let's let's print the book. Okay, finally, let's print the result. So we need to subscribe. Okay, so result, so final output. Okay, and result output, and let's create spacing here. Okay, nice. Here we have static method. Here we have our stream. We are operating some. We are using some operators here. Map. We are removing the spaces. We are to uppercase those titles. Then we are using do on next method. So just to print something. Then we are using flatMap because we are going to return the mono. That's why we are using flatMap. Then mob logging, and finally we are subscribing. So we are going to print our result. Okay, let's print this and let's see. Notice that there is a space in here. We're not going to see that space, of course. Good. Transform title. Okay, here remove spaces. Uppercase this one. Save to database. And here. Final output. Save clean code. Nice. Summary. Reactive pipelines use declarative operators like map, filter, reduce, and flatMap. Pipelines are lazy. Okay, we have seen that nothing runs until subscribe is called. A processor can act as both subscriber and a publisher, enabling mainstream transformations. Immutability ensures data isn't changed, supporting safe and predictable flows. Side effect isolation by using do on next, do on error. Keeps the core logic pure and easy to maintain. Thank you.